Okay, so welcome to all of you. Today we will discuss the chapter 4 continuity of calculus first. Okay, so first we will define what we mean by a continuity. What we mean by a continuity. Okay, suppose A is the subset of R and f from A to R is the function. Okay, C is the element of A. We say that f is continuous at x equal to C for given epsilon greater than 0. There exists delta greater than 0 such that mod of x minus is less than delta f less than f of x. Same thing has a definition of the limit. So here we are writing L here. So instead of L there should be the f of c. Only this change is there. Okay. So that is what limit x tends to c, f of x is equal to f of c. This is same as limit x tends to a. Limit x tends to a, f of x is equal to f of a. So then we say that the function is continuous at x is equal to a now. Okay. So this is the definition actually. So f is the continuous at x is equal to a if limit x tends to a, f of x is equal to f of a. So this is the definition. This is the epsilon definition. Okay. So but while solving the problems we are using this definition. Limit x tends to a, f of x is equal to f of a. So what happens here? If f of a is not defined, then function will not be continuous at x is equal to a. Okay. So if limit x tends to a, f of x do not exist, then also the function is not continuous. Okay. So if this is not equal to f of a, then the function is not continuous at x is equal to a. Limit is exist, f of a is defined, but they are not equal. The function will not be continuous. Okay. So now this means that when the function is continuous at x is equal to a, then this happens. Limit x tends to a plus f of x. This is right hand limit. Limit x tends to a minus f of x is equal to f of a. So if all these three are equal, then your function is continuous at x is equal to a. So if a function is continuous at x is equal to a, then limit x tends to a plus f of x is equal to limit x tends to a minus f of x is equal to f of a. Remember that. Okay. So with the help of this definition, we'll solve some problems on the continuity. Okay. So first we'll see some examples of which functions are continuous, which functions are not continuous. Okay. So suppose f of x is equal to c. F of x is equal to c. So this is a constant function. This is a constant function. Okay. So constant function is always continuous. Okay. It's continuous for all x belong to R. Right? Everywhere it is a continuous. Everywhere it is continuous. Okay. So that means it is continuous over R, the set of the real number. Okay. Now suppose we have this function f of x is equal to x for all x belongs to R. Now this is identity function. This is identity function. It is continuous. It is continuous for all x belongs to R. That means it is continuous everywhere in R. Okay. So the next example is what? Suppose we have given this f of x is equal to 1 upon x. 1 upon x. So it is not continuous. Is not continuous at x is equal to 0. Because it is not well defined at x is equal to 0. So that means what? This function is continuous on a is equal to x belongs to R such that x not equal to 0. Such that x not equal to 0. Okay. So you may say this is what? Suppose we have given this domain x belongs to R, x is greater than 0, the function is continuous. X is less than 0, the function is continuous. No problem for this one. The function will be continuous. Okay. So if x is greater than 0, x is not equal to 0, or x is greater than 0, or x is less than 0, or in all this domain, your function will be continuous. Okay. So but in general, f of x is equal to 1 upon x is not continuous at x is equal to 0. Okay. So now if your domain is like this, then the function will be the continuous. Because what? In your domain x not equal to 0. This function is not continuous at x equal to 0, but x is equal to 0 is not in the domain. So that means it is continuous everywhere in this domain. Okay. So note this. Now suppose you have this function f of x is equal to 1, x is rational, and 0 x is irrational. Okay. So if such type of function is there, so for here what, if your x is rational, then the function is converges to 1. If your x is irrational, then your it is convergent to 0. That means it has two limit points. That means limit does not exist for any. Okay. So this is not continuous. This is not continuous for all x belong to R. It is not continuous for. So that means it is nowhere continuous. This is nowhere continuous in R. Nowhere continuous in R. So it is not continuous anywhere. For any real number, it is not continuous. So that means it is nowhere continuous. So remember this word, nowhere continuous. So here what, there is 70% syllabus is there. So I think only the, okay. Now suppose the function is defined like this. F of x is equal to x square plus x minus 6 upon x minus 2. X not equal to is continuous at x is equal to 2. Find f of 2. Find f of 2 so that f is continuous at x is equal to 2. Okay. So if they ask find f of 2 if this is continuous at x is equal to 2. So if this function is continuous at x is equal to, okay, so that is continuous, okay, no problem for this one. Okay. So here what this means it is continuous at x is equal to 2. So find f of 2 so that this function is continuous at x is equal to 2. So what you have to do only, so for f of 2 just you have to find limit x tends to 2 x square plus x minus 6 upon x minus 2. Only I have to do this one. So only what you have to do. So see here, this is 4, 4 plus 2 is 6, 6 minus. This is 0 by 0 form. Just factor this. This is x minus 2 is a factor. So find the other factor. Other factor will be x minus 3. Other factor will be x plus 3. Because this is minus 6 and this is what? Minus 6. Only I have to adjust this. Okay. So now only here what? This what? Limit x tends to 2, x plus 3. So x plus 3 is what then? 5. So f of 2 should be the 5. Choose your option. F of 2, this will be 5 now. Okay, so where it is 5. Now, suppose you have this function, mod x is equal to x square plus bx plus c. This is a quadratic function, polynomial function, right? It is continuous everywhere. So f is continuous for all x belong to R. Whatever a, b, c may be. Whatever a, b, c may be. Okay. So this is a polynomial function is always continuous. For if it is given twice x square plus 3x plus 7 something like this. This is the second degree polynomial equation. So it is continuous everywhere. Any polynomial, any degree of that degree may be anything. So if it is a polynomial function of any degree, is always continuous over R. Over R. Everywhere that is a continuous. Okay. So note this. Now similarly, f of x is equal to mod x. Because what is this is well defined for any real number. Every real number this is well defined. That means this function is continuous for all x belong to, is continuous for all x belong to R. So mod x is continuous everywhere. Note that. Mod x function is continuous everywhere. So on R it is continuous. Okay. Okay. So suppose f of x is equal to x square plus twice x plus 1 upon x square plus 1 upon x square plus 1. Now we have to discuss the continuity. We have to discuss this continuity. So now here see where the denominator, this is the rational function. This is the rational function because this is a polynomial upon polynomial. Whatever the degree of the numerator and denominator may be. Okay. So this is polynomial upon polynomial. So it is a rational function, and we know that rational function is continuous everywhere except at the zeros of the denominator. Okay. So at what value of x your denominator will be 0? So see, this is x square, it is positive, 1 is also positive, sum of two positive number is 0. So there does not exist any x such way that your denominator is 0. So that means what here is continuous for all x belong to R. Everywhere it is verified, that means it is continuous for all x belong to R. So it is continuous everywhere because denominator there is no x such way that your denominator is 0. Okay. So denominator has no 0, that means this is a continuous everywhere. Okay. So that algebra is also there. Sum of two continuous function is continuous. Product of two continuous function is continuous. Okay. So division of two continuous function is continuous if denominator limit of the denominator is not 0. Okay. So now we will discuss the discontinuity of the following function. Suppose your f of x is equal to 1 upon x minus 2 minus 3x. Okay. So here what f is not continuous at x is equal to 2. Okay. So that means f is continuous. F is continuous for all x belong to R except at x is equal to 2. That means what? This domain x belong to R, x not equal to 2. This is your domain. Okay. In this domain, the function is continuous everywhere. Okay. So that means this is the discontinuity. X is equal to 2 is the discontinuity. Not continuous like this. Okay. Suppose f of x is equal to 1 upon x plus 2 square plus 4. Okay. So what happened here? Where the denominator is 0 at x is equal to minus 2. So x is equal to minus 2, your function is not continuous. Your function is not continuous. Okay. So now if your function is like this, x square plus 4x plus 3. Okay. So we will solve this denominator. Will equate to 0. Okay. So this is what then x plus 1, x plus 3, x plus 1, x plus 3 is equal to 0. That means x is equal to minus 1, minus 3. So that means what? F is not continuous. F is not continuous for x is equal to minus 3. You add x is equal to minus 1 and x is equal to minus 3. Okay. So this is a rational function, and rational function is discontinuous at the zeros of the denominator. So minus 1 and minus 3 are the zeros of the denominator. So therefore it is not continuous at x is equal to minus 1 and x is equal to minus 3. Suppose we have this function x plus 3 upon x square minus 3x minus 10. Okay. So we will equate the denominator as 0 now. So the product is 10 minus 10 and sum is minus. So this is what? X minus 5, x plus 2 is equal to 0. Easily you can factorize this because the coefficient of x square is 1. Okay. If you get the number, the product is what? Minus 10 and sum is minus 3. So numbers are minus 5 and 2. Minus 5 and 2. So coefficient of x square is 1. Directly you can factorize this. So this is what then 5 minus 2. So that means what? Your function is not continuous at 5 minus 5 and minus 2. Okay. Now suppose we have this function mod of x minus 1 plus sin x. So note that this function is continuous everywhere. This function is continuous everywhere. X minus 1 is continuous. Mod of x minus 1 is continuous everywhere. Sin x is also continuous everywhere. Trigonometry function sin cos, sin and cos, they are continuous everywhere. So therefore what? This is the x mod is continuous and sin x. Sum of two continuous function is continuous. So this is continuous for all x belong to R. Okay. Suppose we have this function 1 upon mod x plus 1 minus x square upon 2. So now this is the mod x. So whatever the x may be, so this denominator is the sum of positive term. So it will not 0. So here denominator will not be 0 for any value of x. So when x square upon 2, this is the polynomial function of degree 2. So this is continuous everywhere. This is continuous everywhere. And difference of two continuous function is continuous. So this is continuous for all x belongs to R. This function is continuous everywhere for all x belongs to R. Okay. So now this function, suppose sin x upon x. So here we have given only this. Okay. So if this is what x not equal to 0. If it is 1 for x is equal to 0. If your function like this, sin x upon x, x not equal to 0, and is equal to 1 for x is equal to 0. Now this function is continuous. But this is not provided to you. This is not provided to. Only I have provided this, the f of x upon sin x upon x. So it is not continuous at x is equal to 0. It is not continuous because what here f of 0 is not defined also here. So this is what 0. If x is 0, then this is not defined. So that means x is equal to 0 is the discontinuity. Okay. So define next. Define f of 3. Define f of 3 such that f of x is equal to x square minus 3 x not equal to 3 is continuous at x is equal to 3. Okay. If your function is like this, so what is the f of 3? Just you have to find limit x tends to 3, x square minus 9 upon x minus 3. So this is what then limit x tends to 3, x square minus 9, this is 0 by 0 form. So factorize this, x minus 3, x plus 3, x minus 3 get cancelled. So this is x plus 3 and this is 6. So choose the option 6 where it is option 6, just choose that. Okay. So define h of 2, so that f of x is equal to x square plus 3x minus 10 upon x minus 2, x not equal to 2 is continuous at x is equal to 2. Just you have to find this limit. So this is what then x plus 5 and x minus 2. X plus 5, x minus 2. So upon x minus 2. So x minus 2 get cancelled. So this is 7. So f of h of 2 will be the 7. If h of 2 is 7, then your function is continuous. Otherwise the function is not continuous. So now define g of 1, so that g of x is equal to x cube minus 1 upon x minus 1, x not equal to 1 is continuous at x is equal to 1. Okay. So only I have to factorize this. So factorize what? X minus 1, x square plus x plus 1 upon x minus 1. So x minus 1 get cancelled. So this is what then 1 plus 1 plus 1. So this is 3. So g of 1 will be what? 3. G of 1 will be 3. Okay. So such problems will be asked. Okay. So it should be asked. So you should ready with that problem. Okay. So we have discussed almost. We have discussed more problems. Okay. We have already studied the details, the chapter continuity. Just you revise this. Okay. Once again. Okay. So now we stop here. Okay. Thank you.